Hi everyone, here I am in Desmos, and so if we had been in class when doing section 2.4, I definitely would have been bringing this up on the projector. So first thing I'm going to do, let's go and graph y equals 2x to the third plus 5. This was a big example for us. So 2x to the third plus 5 looks a little something like that. Okay. And we had found the equation of the tangent line. Let me go back. The slope of the tangent line was 6, and it passed through the point 1, 7. So I'm going to graph that point 1, 7. Right? That was the point in question. And we wanted to know what is the equation of the tangent line right there. So we first found the slope to be 6, but then we used the fact that it was 1, 7 to get the equation of the line. And we realized it was y equals 6x plus 1. And so there it is graphed. That green line is your tangent line to the red curve right at that moment right there at that blue dot. And that is pretty amazing. I mean, that green line, if we were to zoom in, that green line only touches that red curve at that one point. It's below it everywhere else, but you can see it's moving perfectly in the same direction at that one point. And as you zoom in, right, the two start to blur together because it's so close. And we just did that. We did that ourselves. We didn't graph anything. You know, it took a few lines, but not a terrible amount of work for what we've accomplished there. I mean, that is very, very powerful mathematics that we're working with. Okay. So then we went ahead and we looked at y equals 16x squared. And it's this very steep parabola like so. Okay. And we found the derivative function f prime of x to equal 32x. And we realized just some slopes. We played around with some of the slopes of the tangent line. So we saw, you know, at 3, the function's at 144. So this is very high. If I zoom out, oh gosh, okay, there's 3, 144. Now we didn't find the equation of the tangent line there, but we did realize the slope was 96. So an incredibly steep slope. Let's go ahead. I'm going to put it in there. So if we know the point is 3, 144, I can just go y minus 144 equals 6 times x minus 3. Oh, it wasn't 6, 96. What am I doing? The slope was 90. Okay, there it is. Oh, wow. Yeah, it's hard to even tell the difference between the purple and the red. Because it's just so steep, but there it is. There's the slope of the tangent line there. Okay, we also, we played around with some other numbers. I showed you guys what's happening at 5. The slope is 160. Okay, let's get rid of that. Also at 0, 0, right? So the origin is an interesting point. Let me highlight that. And we can tell, yeah, the slope right there, just visually, the tangent line's got to be perfectly horizontal, right? It's kind of just graze by, and yep, you know, y equals 0. That green line there would be the equation of that tangent line. Okay. Okay, then we really went for a good one. Toward the end, our last example was y equals 2, and it had a square root. So to get a square root, type in SQRT, and when you hit the T, it gives you the square root, which is pretty cool, x plus 1. All right, so let's see. Okay, there is 2 square root x plus 1. It's got that square root shape to it. It goes through 2. Notice that it begins there at -1. Okay, so we realized we found the derivative function to be f prime of x equals 1 over square root x plus 1, which caused us to realize, hey, the derivative does not exist at -1 or for any value less than -1, because that would give you an imaginary number. in that denominator, and we don't work with that sort of thing in calculus. But at -1 in particular, because -1, right, in the original function would give you 0. And yeah, that's where the point is. Yet there is no tangent line there. And the reason why, a tangent line always needs a left side and a right side. You can't do one-sided tangent lines. So even though the function exists at -1, we cannot draw a tangent line there because there's no left side to it. And so there you go. Also, there's kind of another reason too. Now that I look at it, the tangent line here would actually be vertical. As this thing comes back down, it's getting steeper and steeper and steeper, and right at the moment it hits the x-axis, that tangent line, if there was one, would be perfectly vertical. And of course, that would be, it'd become a vertical line, and the slope is undefined at that moment. Okay, very, very cool. That's all I wanted to show you.